the area of quantitative techniques. So today we'll be discussing the dominance property of the game theory. It is a very important theory which game theory has given, right? So these are some. This is one of the most important theories or probably properties that are used for solving the game theory problems, right? So we'll start with the introduction. So introduction is dominance property. What do you understand by dominance property? So it is an observer that uh, one of the pure strategies of either player is always inferior to at least one of the remaining ones. So when pure strategies are applied, it is being observed many a times that the probably one of the players have a very strong strategy against the other. So this is always the case, right? This is probably a major case when two players are playing a game. One probably had a very strong strategy against their opponents, right? The superior strategies are set to dominate the inferior ones. This is so but obvious, right? Clearly, a player would have no incentive to use inferior strategies which are dominated by the superior ones. In such cases of dominance, we can reduce the size of the payoff matrix by deleting those strategies which are dominated by others. So, what we do is we reduce the matrix size by deleting those strategies which are dominated by the others. So, there is a 50-50% chance of getting both of them win, right? In case of dominant strategy, obviously the one player having the dominant strategy will win. But since to reduce the chance to have a fair game or reduce the inequality, uh, delete, we reduce the size of the payoff matrix, right? Thus, if each element in one row say kth, so these are some of the rules probably I would say which are used by the game theory to find out the dominant strategy, right? Thus, if each element is one in one row, say kth of the payoff matrix is less than or equal to the corresponding elements in some other row, say rth, then player A will never choose kth strategy. The value of the game and the non-zero choice of probabilities remain unchanged even after the deletion of the kth row from the payoff matrix. In such a case, the kth strategy is said to be dominated by the rth one. So there are some general rules and regulations which are used by the game theory to probably rule out the property of dominance or to find out the dominant strategy in the payoff matrix. These general rules are like this. Uh, for player B, who is assumed to be the loser, right? If each element in a column, say CR, is greater than or equal to the corresponding element in another column, say CS in the payoff matrix, then the column CR is dominated by column CS, and therefore column CR can be deleted from the payoff matrix. In other words, player B will lose more by choosing strategy for CR column than by choosing strategy for column CS. Therefore, he will never use strategy corresponding to column CR. Right. For player A, who is assumed to be the gainer, if each element in a row, say RR, is less than or equal to the corresponding element in another row, say RS in the payoff matrix, then the row RR is dominated by row RS, and therefore row RR can be deleted from the payoff matrix. In other words, player A will never use a strategy corresponding to row RR because he will gain less for choosing such strategy, right? So this is the third one which is given in the modified dominance property section. So the last one says that a strategy, say K, can also be dominated if it is inferior to an average of two or more other pure strategies. In this case, if the, the domination is strict, If the domination is strict, then strategy K can be deleted. If strategy K dominates the convex linear combination of some other pure strategies, then one of the pure strategies involved in the combination may be deleted. The domination will be decided as per rules 1 and 2. So the domination will be decided based on the rule number 1 and 2, which I have discussed in the slides, in the previous slides. So this slide is just an overview of what we have discussed till now. A strategy is dominant if it outperforms all other choices, no matter what opposing players do. Strict is always greater than, and weak is always used choosing greater than equal to. Games with dominant strategies are easy to analyze. If you have a dominant strategy, use it. If your opponent has one, accept expect her to use it, right? So this is an example where dominant strategies can be used or is used, right? I have given an example of two companies where Philip Morris and Reynolds gives their payoff matrix when there is no advertisement and there when there is advertisement, right? So Philip Morris and Reynolds are the two giants in their sectors, right? So when there is no advertisement from both the companies, the cost, or would I would say the profits, the revenue is 50-50. And if there is advertisement from the Philip Morris, sorry, so the your that payoff matrix or your revenue goes to 60, and for Reynolds it goes to 20. And for in case of no advertisement from the Philip Morris and advertisement from the Reynolds company, the revenue goes 60-20, 60 for Reynolds and 20 for Philip Morris. And similarly, if there is advertisement from both the from both the companies, so there is a 30-30 revenue for both the companies. So both players have a dominant strategy. So they both the players have a dominant strategy where they can dominate and probably get more returns or more revenue out of this, right? So in this case, the first one, which is 50-50, is the optimal strategy, and the last one, which is 30-30, is a equilibrium strategy where both the companies will be earning equal after spending their advertisement cost, after probably deducting their advertisement cost. But optimal one is when there is no advertisement from both the companies. In that case, both the companies will be earning 50-50 revenue, which is an optimal case, right? Uh, Equilibrium outcome results in lower payoffs for each player. Game of the above form is often called the prisoner's dilemma. It is also called a prisoner's dilemma, right? Pricing without dominant strategies. So there are, very less chances of having a dominant strategy in a game, right? So if we found one, we are so lucky, right? I'll take another example where prices are decided without the dominant strategies. So example here is where there are two cafes, Cafe 1 and Cafe 2, which are competing over the price. So we have a two group of probably customers that are prevailing in the city. The first one is the tourists, which are 6,000 in number, doesn't have any information about the city but want coffee. And there are 4,000 locals who are addicted to caffeine but want the cheapest coffee. So in this case, what will be the payoff matrix, right? Cafes offer the same coffee and compete over price. Tourists don't know the price and half go to each cafe. Therefore, cafes offer the same coffee. So this is a condition which is given, right? And they're competing over the price. And the tourists don't have any information. So it is said that half of them are going to Cafe 1 and half of them are going to Cafe 2. That means around 3,000 tourists are going to Cafe 1 and 3,000 tourists going to Cafe 2. Suppose we change this, we take the scenario forward or change the scenario some bit. Cafe 1 charges $4 and Cafe 2 charges $5, right? We have assumed that Cafe 1 is charging $4 and Cafe 2 is charging $5. So recall tourists are dumb and don't know where to go. Therefore, Cafe 1 gets 3,000 plus 4,000 locals. That means that 7,000 customers, but at a cost of $4, which will be $28,000 or $28,000, right? And Cafe 2 gets 3,000 tourists plus zero locals. That means they are getting only 3,000 customers at a price of $5,000 and they'll be getting $15,000 rupees. So that's how we calculate the value of the total matrix, and we again now draw a 3 by 3 matrix, which is of 2, 4 or 5 price selection, 6,000 tourists and 4,000 locals. So this is a payoff matrix which has been drawn using the numbers, using the information given in the previous slides. So there is no dominant strategy here where Cafe 1 can be dominant and Cafe 2 can be of inferior choice, right? And Cafe 2 be dominant and Cafe 1 have a inferior choice. So this is an example of dominant and non-dominant strategies, right? I'll be discussing more about this quantitative techniques in the coming lectures. Thank you so much.